Hi, welcome back to the class. R for journalists. We are in the last section for how to transform and analyze data using dplyr. This time, this section, we're going to go over this concept called pipes. Data analysis will often involve more than one step. You've already seen this so far in our class. We're going to go over some options on how to approach a multi-step process with this data set, the murders data set, and then we'll go over the best way to deal with them. So let's go over the theoretical process on steps we want to run on this data set. So step 1, extract rows from cases that happened in Washington, D.C. Then let's group it by year, and then count the number of cases, and then arrange this data set by decreasing cases so we can see which years had the most. Okay, so option 1 is to build out a data frame for each of these steps. So let's say DC annual murders 1. You start by one, like I said, filter. Murders is the data frame. State equals District of Columbia. $8,000. So let's go to the next step. Group up by year, so we can summarize. We'll call that murders 2. Group by, and I pass it this new data frame we created called DC annual murders 1. And then I want to group by year, like I said. Okay, so the same thing. It looks exactly the same, but this time the years are grouped, so that's better. Now, DC annual murders 3. Summarize DC annual murders 2, which was the previous data set. And this time I want to count up the numbers, right? So I'm going to do a new data frame, new variable called total equals, and how do you find the number of things in summarize? That's n parentheses. And so I've narrowed it down to 35. There are 35 years worth of murders in DC. So DC annual, now I want to arrange it, right? So to rank it, pretty much. Murders 4, and that's arrange DC annual murders 3, which is the last data set we created. And then in descending order, total. So 1991, 90, 92. And you see how that kind of differentiates from this? All right. Option 2 is to nest it all, which you can totally do in R. A lot of people do that in base R. So let's say DC annual murders. It's going to be a pain, but let's say what? You're going to start out first with, I can just copy this, filter. Murders, state equals District of Columbia, and then I nest that, right? Because this is a data frame in itself after I do this. So then I can nest that group by, comma, year, and then I can nest this, summarize, comma, come on, let me click, comma, total equals n, and then nest that, arrange is the last step. It's getting unwieldy, comma, descending total. Oh, see, this is the problem with all these nested parentheses, is that sometimes you lose track of them. Did this work? Oh, yeah, it did not work because it's got descending total because it thinks it's a new data set. It's not. It's because I forgot to put a parenthesis. That's the thing. Did I? Yeah, let's see if that works. Okay, so it worked that time, but this is horrible because if you didn't write this code and someone's coming in and you're coming and trying to decipher what I had written, you'd have to first kind of like do a backward step. It's like, okay, the last step was arrange, second to last was summarize, then group, and you have to like dig all the way through to see like what the first thing was, which was filter, and that's a pain. And so compared to option one's better because it's way more readable, but you're still typing way too much. So I want to talk about the pipe operator. So you see, you notice how all these functions are structured very similarly. The first argument is always the data frame. Okay, so because it's organized that way, it's easy to use this function. Well, this command called a pipe, and it looks like this: %, %. Okay, it's very powerful. So what it does is it takes something on the left and passes it and assumes and it lets the function that follows know that it assumes that that's the data frame. Okay, so the illustration here is much better at kind of illustrating that. I will also show you how it works, and maybe that'll clear it up. So let's see. These commands do the same thing. So filter murders of age equals 2. Gotta type the name of the data frame correctly. Okay, so that is how you would see the filter function work normally. But if you use a pipe, all I have to do is you start out with the data frame and you type in the pipe, and this time when you put in the function, you don't have to pass it. The first argument doesn't have to be there anymore. Okay, so you see they both gave you the same thing because this is that. Okay, so because I use a pipe, I can do it this way. So in essence, a pipe is the grammatical equivalent of and then. So let's go over the process again, which was filter by District of Columbia, group by, summarize, and then arrange. You just can start out with the data frame, murders. Actually, we want to assign it to something, right? So, actually, no. Let's start out with the data frame. Why not? Murders, and then you use the pipe, filter, and I don't have to pass the variable, the function, the argument, data frame anymore. I just go straight into what I want to filter it by. And then pipe, group by, and then I don't have to pass it anymore because it's taking the thing from above previous to it, and I want to group by year, and then summarize. So you see where I'm going with this? Total equals n, and then arrange descending total. Okay, so let's run this. That's it. So what's great about this is you can kind of run this line by line. You don't want to run the line with the pipe though, because it's expecting, you see the plus sign, it's expecting something. So if I was to troubleshoot this, you can do this line by line, pretty much up into the pipe. So that is the first step. I've got about 82,000. Then I group by. So now things are grouped by year, you see. Well, I guess you couldn't see it. So then next step. So I'm holding down the shift key and selecting between. Alright, so you see that summarize it and give me total, and it's starting to order it by the year. And then I can run the last line. So you can see step by step how it's evolving, which is great. Another cool kind of shortcut I'm going to show you is you can add a null in here. So this is a way to, once you start programming often, well, never mind, that's not going to work in here. Okay. I spoke too soon. Null is a trick to work with ggplot2, so just pretty much ignore everything I just said, and just soak in the fact that you are able to understand pipes now. It's much more readable than this. It just saves you a lot of time, and you don't have to just keep creating new data frames that clog up your memory. So a shortcut to get the pipe in RStudio is Command Shift P. Oh, sorry, Command Shift M. In Windows, it's Control Shift M. So why the M? I think it's because of the original package that it was created for is the Magritte package by Stefan Milton Bosch. I might be messing up the pronunciation, but it looks like this. Okay, and this is where the concept kind of first came up. You'll see it in other languages. In Linux, it's pretty much the pipe. So, next, after pipes, I'm going to talk about mutate again. So there's a lot of things, interesting things that you can do with mutate. Let's try out lag with mutate to do some math based on the previous row of a vector. For example, in the data frame, we've got the number of murders in DC. So we've already created that. Let's do some math and calculate the difference in the number of murders year over year. So I want to get rid of, I can just repurpose this code we've used before. And murders, filter, district. I don't want to arrange by rank anymore, so delete that. But instead, I'm going to create a new step called mutate and create a new column called previous year. And all I do is just equals lag is the function, and I pass it lag of total. And so what happens? How does this look? Very cool. So you see here, the previous year on the right of it, 2002. The previous version of total was 23. Let's go to here, 232. The previous year was 180, and now it's over here. Why do you want to do that? So you can do some math. Let's do another mutate. Let's add a pipe, and then do another mutate, and create a new one called change equals previous year minus total. Let's run that. And now we can see the evolution of murders. Okay, so mutate works well when you have a formula that you want to pass it, and it returns vectorized output. For example, if a vector has 10 instances in it, then the formula needs to output 10 instances as well. So if you pass it a formula like sum, it would confuse it. So let's say we did I'm going to save this as years, first of all. Arrow years. Double check years. Okay, we got the data frame saved. What if we passed it mutate all murders equals sum of total. So now it took the result of total here and it shoved it at the end, which might not be what you want. So this is what differentiates mutate from summarize. Summarize, you would want this type of thing. Mutate, you probably don't. There's a list of great summary functions. Standard deviation is SD. Quantiles are very useful. Range, I just showed you min and max. There's absolute as well. N distinct, first, last, and nth are very powerful as well. So let's look at group by one more time. So let's put everything we've got so far and figure out how to do percents. So we can summarize data by how many men were murdered versus women by doing this. Murders, pipe, group by, victim sex label. And then summarize, total equals n. So this would give us a summary of. Okay, press escape once you're stuck in this little console thing and it's looking for like the continuation of it. To cancel it, press escape in console and you'll get the caret again blinking and it's ready for more commands. So first group, so we have total victims in this data set. By grouping the gender for all instances, we can now drill deeper. So watch what happens when we add state in here. Now we've got the state on the left, the victim label in the middle column, and you've got total. So this is interesting, right? The structure for this data here might be foreign to you. As it stands, the data is considered tidy. Each variable is a column, and each observation or case is a row. This makes it easier to analyze data in R and create charts. But you're probably used to data that looks wider, like the state plus victim label, male, female, unknown, all as variables, and then the total underneath each one. So each state would have a single row, instead of here where it's 3 rows because there's 3 types of labels for gender. The tidy structure makes it easier to run calculations like percentages. All right, it's just something you kind of get used to. It's a new way of thinking of working with data, and I'll show you how. So we can chain all this together and make percentages based on the verbs we've used by doing percent. I'll create a new data frame called percent murders pipe group by, pretty much the same thing as before. Pipe it summarize total equals n, and now we've got the total. Now we can do some math. So we do mutate. Percent is the new variable we want to create, and this is where it gets a little tricky. All right, total, because this is what it looks like, right? Total divided by sum of total times 100. Take a look. It adds up, right? 565 females in Alaska amounts to about 29%, and that leaves 71% left over, and plus 0.1 for the unknowns. So it didn't add up all the total, the sum of everything in the total, right? Before doing the math, it just summed up everything within the group, and then divided up this total divided by the sum of the grouped total. Okay, it's a little hard to get used to at first, but you'll get there. So we can use dplyr verbs to find something more of interest after this. Which states have a higher percentage of women murdered? Oops. Add a pipe here. Actually, just repurpose my code. Add the line now. Filter vic sex label equals female. And then, because I just want to see right away which ones are the worst areas, do arrange minus percent. Sometimes the minus won't work as a descending indicator in dplyr. If that's the case, then just do the old-fashioned way with this DESC percent. But I think it worked in this one. Yeah. So Maine, Vermont, New England is not great for women. Okay. So congrats. We've gone through a bunch of ways to analyze data. And next we're going to figure out how to use tidy data and how to join data. So I'll see you in the next video.